So in this lecture, we are going to discuss about the next unit, that is microprocessor, microcontroller and interfacing. So we will discuss what are the requirements of interfacing and what is the term interfacing refers to, and what are the types of interfacing and how the interfacing controllers work, etc. So what is this interfacing? We know that interface is a path for communication between the two components. Interfacing is of two types, that is memory interfacing and input-output interfacing. So let us discuss about the each one individually. So memory interfacing, when we are executing any instructions, we need the memory microprocessor to access the memory for the reading instruction codes and the data stored in the memory. For this, both the memory and the microprocessor require some signals to read from and write to the register. The interfacing process includes some key factors to match with the memory requirements and microprocessor signals. The interfacing circuits therefore should be designed in such a way that it matches the memory signal requirements with the signals of the microprocessor. Input-output interfacing. There are various communication devices like keyboard, mouse, printer, etc. So we need to interface the keyboard and other devices with the microprocessor by using latches and buffers. This type of interfacing is called as input-output interfacing. The microprocessor cannot do anything by itself. Therefore, it needs to be linked with the memory, etc. and peripherals or input-output devices. This linking is called as interfacing. So the interfacing of the input-output devices in 8085 can be done in two ways. One is memory mapped input-output interfacing and input mapped input-output interfacing. In this kind of interfacing, we assign a memory address that can be used in same manner as we use a normal memory location. A kind of interfacing where we can assign 8-bit address value to the input-output devices which can access using input-output instruction is called as input-output mapped with input-output interfacing. Next, we will discuss about the difference between these two types. So first of all, we will start with the addressing. In addressing, we know that input-output devices can be accessed like any other memory location, where they cannot be accessed like any other memory location. Address size, we have 16-bit address values, whereas in input-output, we have only 8-bit address values. Instruction used in are load, LDA and STA, etc. Whereas in input-output memory, we have the instructions like in and out. Cycles involved during the operation of memory read, memory write. Whereas in input-output, it involves the operation like input-output read and input-output write in case of input-output mapped with input-output. So we have the difference, right? Memory read and memory write. Here input output read and input output write. Registers communication. Any registers can communicate with the input output device in case of memory mapped input output, whereas only accumulator can communicate with the input output devices in case of input output mapped with the input output device. And next, discussing about the space involved, here we can have up to 2 power 16 input output ports. It is used for interfacing, whereas here only 256 input output ports are used. And input output signal or memory signal, during the writing or reading cycles, input output bar memory is equal to 0 in case of memory mapped. The status will be 0, whereas in case of input output it will be 1. Then control signal. No separate control signal required since we have unified memory space in case of the memory mapped input output, whereas special control signals are used in case of input output mapped with input output. Then last one is arithmetic and logical operation. Arithmetic and logical operations are performed directly on the data in case of memory mapped with input output, whereas arithmetic and logical operations can be performed directly on the data in case of the input output mapped with input output. So the difference is both memory and input output devices are mapped with either of the devices. For example, if you are getting a memory card connected or pen drive connected to the lab, the pen drive here strives as a memory device, whereas the laptop will be the input output device. For example, if I am transferring a data from a mobile to the laptop, here both the devices are input output devices. So these are the two different types of devices interfacing with each other. In the next, we will discuss further the interfacing standards. Thank you. Here in this lecture, we are going to discuss about the USART, A251 USART. So USART is nothing but Universal Synchronous Asynchronous Receiver Transmitter, which acts as a mediator between the microprocessor and peripheral to transmit the serial data into parallel form, or as vice versa. It takes data serially from the peripheral, that is output devices, and converts into the parallel data. After converting the data into the parallel form, it transmits it to the CPU. Similarly, it receives the parallel data from the microprocessor and converts it into the serial form.